Students, we are going to be studying about the parametric form of the ellipse x squared over a squared positive y squared over b squared is equal to 1. So foremost we will draw that ellipse. So this is the x-axis, y-axis. So the ellipse is going to be something of this form. And this is O. Let me take a point P on the ellipse. So P is a point on the ellipse. Okay, so let me write it down. Let P of x comma y be a point on the ellipse. Now we would not be able to obtain the coordinate for P because it is a point on the ellipse. So what we will do is we will construct a circle, an auxiliary circle around ellipse. So we will construct an auxiliary circle around the ellipse and let Q be a point on the circle. So if I were to take a point, say Q on the circle, and if I were to connect O with Q and then assume that, in fact, instead of taking it as O, let me take this point as C and let CQ make an angle alpha with x-axis. This is going to be alpha. Now drop a perpendicular from Q to x-axis at the point M. So from Q you drop a perpendicular on the x-axis and name it as M. So this is going to be 90 degrees. Okay, and P is a point on the ellipse and the line is actually passing through the point P. Now clearly CM is equal to A times cos alpha and CQ is equal to A times sin alpha. This would mean Q is A times cos alpha comma A times sin alpha, and since P is a point on the ellipse, its coordinates will be P of A cos alpha comma y1 because it is a point on the ellipse. So this is what we've got. Now consider the standard form of the ellipse: x squared over a squared positive y squared over b squared is equal to 1. Now since P is a point on this ellipse, we can rewrite 1 to be as, in place of x I would be substituting A times cos alpha squared divided by A squared. In place of y squared I'll be substituting y1. So that's going to be y1 squared, b squared is equal to 1. So this is what I've got. I can rewrite this as a squared cos squared alpha divided by a squared positive y1 squared divided by b squared is equal to 1. So a squared gets cancelled. So this would give us, I'm writing down here, y1 squared b squared is equal to 1 minus cos squared alpha, which means y1 squared b squared is equal to sin squared alpha. So this is what we have got. Now what I can do is I can I'm going to rewrite this. So y1 squared divided by b squared is equal to sine squared alpha. From here, y1 squared is equal to b squared times sine squared alpha. So from here, y is equal to b times sine alpha. So this would mean the coordinate of the point P is a times, let me write it down here, a times cos alpha comma b times sine alpha. So this is the coordinate of the point P. And what is alpha? Alpha is called the eccentric angle of the point P. Remember this, alpha is the eccentric angle of the point P. So this completes the solution for this question. And with regard to hyperbola, you can always do the same thing.